So Matrix, day 7 of 7, the final farewell to your trig education experience of lessons. I need to teach you about 4 words and then we call it a wrap. If this seems vaguely familiar, it's because we did do these 4 words in Algebra 2. Like some of what we've been doing has been from Algebra 2, Chapter 4 stuff. These words were thrown at you in Chapter 4 of Algebra 2. So the 4 words of the day are consistent and inconsistent. Every system of equations is either consistent or inconsistent. One or the other, can't be both. Simultaneously, it's either independent or dependent. Now those are 2 unrelated choices. One has nothing to do with the other one. So what consistent means the system of equations has a solution. It might only have one solution, or it's possible it has an infinite amount of solutions, which I can talk about in a little bit. But if there's any numbers that can go in and work, one grouping or lots of groupings, that makes it consistent. Inconsistent means there is not a solution possible. It cannot be answered. There are no numbers that can go in and make the equations all true. You might spot that there's something about the system that's just nonsensical or impossible. Like it can't happen. To this point of the year, have all of your systems been consistent or inconsistent? Consistent. Everything I've given you, you've been able to solve it and get answers like x is 2, y is 3, or whatever the answers might be. Everything till today has been consistent. Some of the stuff on the board is going to be inconsistent. Side choice, independent, means all of the equations at every level are different in some way. Dependent means some of the equations really are the same as another one. Or maybe one equation is like a combination of some others. But you don't, it might look like you have 3 equations, but really you have 2. That's what dependent means, that one of those equations is kind of like an extra one that doesn't necessarily need to be there. Does anybody have a thought on up till now which everything has been? Has everything been independent or everything been dependent? Independent is correct. Even if you think about life, adjectives you might use to describe yourself. Would you rather, as a human being, student, worker, whatever you are, athlete, would you rather be consistent or would you rather be inconsistent? You'd rather be consistent. Consistent is a positive trait. Would you rather, as an individual person, be independent or dependent? We'd rather be independent. You can do things by yourself. That's a good word. So everything till now has been consistent and independent. If you're one of the other words, it means like something went wrong somehow. Okay, so what we're going to do today, I'll give you some systems. We'll try to solve them. You can solve them by whatever means you want to solve them. If you like multiplying with inverses, if you like Gaussian elimination, you like Gauss-Jordan, whatever you like, solve it somehow. If you can get a solution, it's consistent. If you can't, it's inconsistent. If something ends up being the same, that's independent, or dependent. If everything's different, that's independent. So here we go. I'm going to prefer to do what we did the first day of matrix life, which was a thing called Gauss-Jordan elimination, which is I like my 1 where it already is. I'm not going to mess with 2 or 5 right now. But what am I always trying to create under the 1s? Zeros. So I'm going to keep that top left square, and I'm going to try to build my zeros and just see what it looks like. I will say this. If the matrix is not square, it has to be at least one of the bad words. Inconsistent or dependent. If it's not square, something is wrong with it, if you want to say it that way. I don't know that that's fair. Another thing you can check, anytime the determinant is 0, something's wrong. So something's wrong with this. This is not going to be consistent independent. There's going to be at least one of the other ones. Using 1 to kill 3, we multiply by -3. So multiply by -3 and add down. -2. Multiply by -3, add down. -4. And don't forget about that. 1 kills 4 if we multiply by -4. So we get our 0 there. Multiply, add down. -2. Multiply, add down. -4. And then just try to pay attention to your surroundings. I think at this point we can clearly see those two levels are the same. I hope that would catch your eye. That's the same thing twice. Which word is it that describes same thing twice? That is dependent. That is a dependent system because two of those equations are the same. Some people who are shrewd at math might have spotted from the very beginning how this equation really provided no new information. Once I had these, I built this one from these. This is dependent on the other two. This is just a combination of the other two. Now that I pointed that out, can anybody tell me how is this just a combination of those? I just added them together. So if 1x and 2y made 5, and 3x and 4y makes 11, if I add those together, 4x plus 6y equals 16, that's not news. That's what we already knew. Okay? So maybe you spot that at the beginning, that it's just a combination of the others. Maybe you solve it part way and recognize, hey, wait a minute, those are identically the same. If you ever keep going, if you ever got a row of all zeros, 0, 0, 0, 0, all the way through of zeros, because if I did keep solving, like if I used the 2 to kill the 2, the 4 would kill the 4, I'd get a row of zeros. If you go that far and get a row of zeros, that's another signal, it's dependent. Question about that choice? Could we solve this for x and y? Can that be done? Yeah. So since we can solve it, that is consistent. Let's go ahead and get an answer out of it. This is telling you what about y? What's y? 2. And if y is 2, 2 times 2 is 4, do some solving, what's the x? 1. So in the homework, you'll be asked to identify which words it is, and then if it's solvable, solve it, but they're not all going to be solvable. Question about that one? Let me rotate my camera. So before we even get going on this next one, can anybody recognize anything without even doing any work? Yeah, I just took this one and I multiplied by 2 and I made that one. So this isn't anything new. This is just a variation of that one. These two are really the same exact equation. So what does that make the system be? Dependent. If you don't spot that right away, no harm. We could just try to solve it and see what happens. But if you see it coming, right? If we use the 1 to kill the 2, what would we multiply by to use 1 to kill 2? -2, which makes this 0, 0, 0. Which I had said a note ago, if you get a whole row of all zeros, that is going to be dependent. There's a paper there for you if you want to grab that. Try to catch the rest of this later. Hang in there. I'll be curious what they decide to do with that. If they say stitch, that's valid. If they say no stitch, I think that's valid too. Yeah, gives you a story though. Can we, how do I want to phrase the question? We know that x plus 2y equals 5. Are there numbers that can make that true? Yeah. For example, 1 and 2. Or for example. And if we wanted to do answers, how many could we do? If I said to you, list me all the answers that can make that true, would that be kind or cruel? Why? Could be fractions, decimal. How many answers would there be? Infinite. There would be an infinite amount of answers. So it does have a solution. It in fact has an infinite amount of solutions. And I said you'd see one of those in a minute, and now it's time for that. But what word is this? Consistent. Because it is solvable. There are things that make those equations true. But I am not going to ask you to come up with an answer unless there's the answer. If it has one single answer, I want it. If it has an endless amount of answers, I don't want any of them. Just ask yourself, could I get answers? Yeah. Do I want to? Oh, move on. Zoom out that one. I could have spotted in the beginning that there was something wrong with this one because the determinant was 0. The determinant would be 4 minus 4 is 0. So something's up. Okay, so if it's not square, something's up. If it's a determinant of 0, something's up. For this one, might this one be okay? To be our normal, consistent, independent? Maybe, yeah. Because the determinant is -2 and it's square, so there might not be anything wrong with this one. We could start to solve it and just see where it goes, because if it is solvable, I'll want you to solve it anyhow. But this one should play out. 137 is fine. Make our 0 happen. What would this be? -2. -4. So y would be, and x would be, and that's the only answer we could ever do. And which words describe this one? Consistent, because we solved it. Independent, because those are different. Something about that. And again, every year I do this, most years I do this, people try to find a way to shortcut them and say, well, if it's this, does it have to be that? No, there is no relationship. Like this time, consistent was independent. This time, consistent was dependent. There's no way to do it. Each choice can be mixed and matched. I think I'm still in camera range over here. Any chance that this one is fine? Any chance that this one is a repeat of being consistent, independent, the two happy words? I'll say no. Any thought on why am I saying no? This has no chance to be perfect, consistent, independent. It's not square. Anything that's not square, like this was a 2 by 2. What shape is this one? 3 by, answer column doesn't count. So that's a 3 by 2. So 3 by 2, no chance. 2 by 2, had a chance. So let's keep my 1, 2, 3. 0 it up. What would this one be? -3 is true. -3 again is true. Before I zero that one up, anybody have a problem with the -3 pair? Click on you, you're quiet. You okay? You with this? Just being your quiet self. Use the 1 to kill the 2. That would force the 2 to make this 1 and this we multiply by -2 and add down. 2. And let's analyze that. Are these the same or are these different? Those are different. And that's certainly different. This had an x. This is telling you 2 different things. This is telling you that y would be, and this is telling you y would be 2. So those are different. Different makes it be independent. Like, can we find solutions that work in every level at the same time? So this is for the first time on our board today. Inconsistent. I might classify this as nonsense, was the word I used over there. This is telling you that y is 2. This is telling you y is 1. Why can't it be 1 and 2 at the same time? It's got to have a pick. You can't have the y taking on 2 answers. That's just not an option. So that's inconsistent. There is no answer that can work at every level because the y's don't even agree with each other. And again, to emphasize the point from a minute ago, there's no relationship here. This independent was consistent. This independent is inconsistent. There's no relationship between those words. We'll go one more time. I'm guessing it's probably going to be a dependent inconsistent, if I'm guessing, because I didn't do that yet. That seems like a thing that I would do. I like do one of every type, but maybe I surprised myself, I don't know. But if we try to attack this, top row we're good. If I make this a 0, what will it make this? What would you multiply by to kill that off? -2. So multiply by -2 and add it down. Is 0. Multiply by -2, add it down. Agree. So then let's weigh in. A word? Either word? Any word? That is independent, because those are different. Those are not the same thing. Those are independent. I said a minute ago a row of all zeros was dependent. This isn't a row of all zeros because of the 19. So, independent. Consistent? Inconsistent? Inconsistent. I would describe this as nonsense. No x's and no y's should always add up to make 0 x's plus 0 y's has to equal 0. You can't have 0 x's and 0 y's add up to -19. That's bonkers. That would be inconsistent. There is no solution for that. It just can't be done. I'm surprised I didn't do one of each type, but I could have if I can. But dependent, inconsistent, it could be a thing. I just didn't choose to.